looks like we're live. Hey everybody, welcome to another C4 live stream. Thanks for joining us today. My name is Kent. I'm on the C4 Certified Ethereum Professional Committee. Today we're going to have a fun chat regarding kind of an extension of what we talked about last time in terms of use cases for blockchain technology. We talked about some of the challenges with mainstream adoption and some of the potential use cases. Today, we're going to turn our collective heads towards the enterprise world. So if you're like me, maybe you've been working in the crypto space, or maybe you don't, but you're not too familiar with the enterprise side of things, the more corporate side of things. If you're like me, maybe you've been working in the crypto space, or maybe you don't, but you're not too familiar with the enterprise side of things, the more corporate side of things. Maybe you've been working in the crypto space, or maybe you don't, but you're not. Sorry, getting a little bit of feedback there. How are we doing on the live stream there?
I think we're good now. That actually it was fun because I often do that. But so I think now we should be good on good to go on it.
It's like I was copying myself.
Well, we got a second set of it in case anybody missed it.
Yeah, nice.
You're sibling yourself.
Yeah, exactly. So yeah, anyway, we're going to hear all about this. So let's introduce the rest of our C4 committee today. Jess.
Hi, I'm the executive director at C4, and I'm excited that Kent is going to moderate today. So thanks for doing this, Kent, and welcome everyone. We're excited to talk about Telecom and Ethereum.
Happy to help. Dustin.
Hi, I'm Dustin. I'm the education manager at C4. I'm based in Singapore and also run a Ethereum community here.
And then finally, last but certainly not least, Sonal, who is part of this committee, but also will be figuring heavily into today's discussion as a practitioner and somebody that's employing crypto in the enterprise space, as we're about to hear about. Hi, Sonal.
Awesome. Hi. Yes, I'm part of the CEP committee, and I am a CEO and co-founder for Interweave. So Interweave is a spin-out from Consensus Mesh, and our team was formerly the Enterprise Zero-knowledge research team. But now at Interweave, we're focusing on enterprise SaaS for real companies to bring privacy-preserving technologies to their processes to enable multi-party coordination. So with that, I'll hand over to my fellow co-founders for their introductions. Mark, you want to go next?
Sure. I'm Mark. I'm the Chief Product Officer of Interweave and co-founder here with Andreas and Sonal. I'll give it to you, Andreas.
Thank you, Mark. Dr. Andreas Freund. Blockchain Swiss Army knife. I've been around the block for a little bit, like 10 years almost in the space. And CTO of Interweave, was also supporting the Enterprise ZK team when it was still at Consensus Mesh. And yeah, I've been around the block a little bit. So I'm very happy to be here, excited to share what we're doing. And we're not doing crypto. Let's just put that out plainly. There is no crypto involved really in our solution, because if it were, guess what? We wouldn't be working with enterprises.
Well, cryptography, right? Isn't that where crypto originally came from in the first place, when people used to say cryptography?
Maybe
a little?
Yes. Yeah. I think that word has long, since the early days of Bitcoin, been adopted to mean cryptocurrency.
Fair enough.
So I just want to make that distinguish for the viewers and listeners, that is kind of important to us, because otherwise you get CFOs jumping out of their seat and going slightly bonkers.
Yeah, so, let's dig into some of those distinctions, because they're very important. And as Jess alluded to, crypto does have different definitions here. It can mean these underlying primitives, mathematical primitives, or it can mean meme coins based on variants of Doge or something. Finally, we have Jeff from Sage. Thanks for joining us today, Jeff.
Hi, thanks for having me. Appreciate it. Just maybe a little bit of background on Sage, by the way. Really appreciate being here. So Sage has been around for about 20 years. We've been operating primarily in the wholesale telecom space. That's the way telecom carriers buy connectivity from each other in A lot of people may not know they do that, but when you're somebody like a Verizon or a BT or an AT&T and you sell a large corporate customer, you don't actually have the network to get to every location you need to get to. So you need to buy connectivity from the same people that you are competing with to win that business initially. So it's a very interesting marketplace. Our experience over the 20 years is that we've spent time in the space where the invoicing occurs, and the invoices are almost always wrong. Not entirely wrong, but percentage-wise wrong, and they add up to big dollars because there's a lot of complexity to it. And the telecom companies are looking for ways to end the constant billing disputes and the constant negotiations of billing disputes. And so while we've ridden that wave over the last 20 years, we're looking now to pivot to a post-dispute world using technology like blockchain to get there.
Awesome. Thanks for the overview. I want to hear from Mark about kind of a high-level view of the tech. But before we jump into that, just to position this project in sort of the pantheon of broader projects in the crypto space. Sonal, I'm curious, two questions. When exactly did you guys spin out from the consensus mesh? And also, how does this relate to baseline protocol? I know this kind of relates heavily to that. I was reading some documentation and some blog posts about baseline.
Yes, so we officially spun out of the mesh at the end of February. So we are about a 1-month-old company. But we've been doing this research around leveraging zero-knowledge for enterprises for a couple of years now. I've been doing it for 2 in my role there. This team at Mesh started in 2019 doing research on the baseline protocol that was founded by that team at that time. So where it weaves in is the baseline protocol, if anybody has followed, is around the same general concepts of helping companies coordinate without sharing information, because that would be the main reason they're unable to coordinate in today's processes. They need to work together because they're partners or even competitors, but they're involved in shared business processes and benefit from coordinating for several reasons, but they can't actually share data because of trust issues, data sharing issues, things like that. So if a standard is implemented where certain technical specifications are met and you can leverage things like zero-knowledge cryptography and other aspects of Web3 technologies, then you can actually coordinate without sharing information through some of the attributes like verified execution, immutability, things like that, that the blockchain technologies bring to the picture. So with the research we were doing for some years around baseline and the use cases that can be applied to, we found ourselves in the lucky position to work alongside the telecom space with a consortium for telecoms named MEF, the Metro Ethernet Forum, where they had standards and accelerator projects that they were working on to solve similar projects and similar problems in the space. So that's kind of how we pivoted from the open source protocol work into a very specific product and demand that we saw in businesses. Andreas was an original teammate for the baseline protocol as well, so feel free to hop in on that evolution.
Yeah, the solution is basically an application of the baseline baseline protocol pattern, and I think could be easily made actually fully standard compliant. It has everything in place basically to do that. So yeah, but the baseline protocol pattern was the one that triggered everything. It's like, oh, that's perfectly applicable here. Let's do it. And Sage had there was also recognized that need, and so when we came together in the context of MEF, it was just natural that we would work together.
Awesome. Thanks. Yeah, excited to also hear more from Jeff about on the Sage side of things and how they plan on employing this. So kind of turning back to the tech side of things, this will cover some of the high level tech, and then we can also get into some of the tie-ins with cryptography and this ZK stuff, because this is a super important element to understand both for this topic, but also it's very relevant to what's happening in the broader blockchain space right now. But yeah, Mark, how does Interweave sort of function at a high level?
Yeah, sure. Thanks. Our product here it's a novel application of zero-knowledge cryptography in the enterprise space, and I think it's important to talk just briefly about what cryptography is, more in the line of the cryptographic primitives vein that Kent mentioned briefly. Cryptography, like at its core, is just a study of the techniques for secure communication in the presence of adversaries. And in the case of enterprise digital automation, we're talking about automating cross-company workflows with your business partners, and that can be it could potentially be an adversarial situation to be in. How do you know you can share information with your business partners? How do you know that they'll be doing the right things with your information once they have it? And if you're trying to coordinate with them, you absolutely must share your data or allow your business partners to work off of your data insights. So, how do we do that? That's the big question. And in basic cryptography, the foundation, there's symmetric key cryptography and public key cryptography, all based around encryption and decryption, where you can encrypt plain text into an unreadable format. Decryption is where you can reverse this process of encryption. And public key cryptography is most widely used now. It's used in Ethereum. You can use it to generate an Ethereum address. You can use public key cryptography for digital signatures, where you can prove the validity and non-repudiability of any transaction you send to the network, any transaction that you receive on that network. And that sort of takes us to zero-knowledge cryptography and the ZK EVM, which is the foundational technology that we're using in the solution, where ZK cryptography it's been around for a while. It's been around since the 80s. And I'll just share my screen real quick to give people a better visualization of what zero-knowledge cryptography truly is. And I think it's best explained with this slide on the screen right here about general purpose zero-knowledge proofs. I think the best way to visualize it is this equation here, where we have a function being evaluated. We have a set of public and private inputs. And once we execute this function with this set of inputs, we can prove verifiably so, mathematically, cryptographically verifiably so, that this statement is true. And these statements can look like a lot of different things. It's very, very composable. An example of a statement that you could prove comes from an example that we implemented during our time at Mesh, where you can prove that a vehicle is within a certain area in a dealership lot without disclosing the true location of a vehicle. That's an example of some way to prove knowledge of information without revealing the clear text information. And that's the big component of what we're trying to do here and what we're actually doing and how we're applying the baseline protocol. And when we talk about zero-knowledge cryptography, there's really three main use cases for how it can be applied. The very simple example is identity management, or simply proving a piece of information, like I said earlier, without revealing the clear text information. But when you hear the term ZK EVM, or how the ZK EVM is being used in Ethereum, it's being used in a different way, actually. It's being used more for compression, where really what's going on here is you're proving correctness of computations or programs evaluating inputs and producing an output without having to reveal or store what was executed, only that it's correct. And that's how ZK EVM L2s are functioning, and that's how they provide value to Ethereum. It's because you can unclog the network, you can outsource this computation to another layer 2, you can do that execution over there, and then you can settle all of those outputs to Ethereum and lower transaction costs, etc. And this is a unique concept when you apply it to the realm of business automation, because what we're doing is we're improving how ERPs are used and talk to other ERPs from different companies. ERPs, enterprise resource planning systems, these are big applications that have been around for a while that automate and eliminate data silos within an individual enterprise, where the accounting team can talk to the marketing team, can talk to the CRM team, all this information is stored in a big database with a big application on top where you can automate processes within a singular entity. But with zero-knowledge cryptography and with the data sharing necessities, like I mentioned earlier, you can't actually link these ERP to them because you run into data privacy issues, regulatory headaches, and zero-knowledge cryptography allows this way to outsource computation that would be required to link cross-company processes in a way that's private and verifiably correct, and is uniquely beneficial in this adversarial situation that you could be in with your business partners. So I think that's a pretty good intro of what ZK is and how we use it. And I think Andreas can talk a little bit more about how we're really leveraging this technology in our solution and helping enterprises.
I know you did an excellent job. I think I think from an enterprise point of view, the key aspect here is actually sort of like complementary to why the whole thing was developed for on Ethereum. By the way, there's a funny story to how actually the whole ZK thing came to be on Ethereum at all. But that's for another time and date. It's a cute story though. The key thing here is that our solution is de facto a black box, right, for everyone, including ourselves, right? It is executing smart contracts, code, Solidity, just like normal, but it's a black box, right? Anybody can only see their own data, and not anybody else's data. Unless of course parties have agreed that they can see each other's data. So that's done through various layers of access control. And the problem is that if it's a black box, you can't see into it. Then how do you know that the entity that operates that black box, right? Because enterprises don't like to operate their own stuff, especially when it involves other enterprises. You somehow need to agree on someone who's like holding the bag, so to speak. And then you need to be able to prove that whatever happens inside that black box is actually correct. And you not only need to prove that to the 2 or 3 or 4 or 5 companies that are involved in a particular process, but to everybody who is operating inside of that black box and to outside third parties such as regulators. And that is why these zero-knowledge proofs are great, because you can prove that everything was correctly done, correctly executed, in a very compact way, just a very short proof. And that can be verified on public Ethereum. So anybody can see it, anybody can verify it. No sensitive information is leaked. So the goal of achieving scalability for public Ethereum has greatly benefited the enterprise space, because it solved a significant problem in the enterprise space, because the private blockchain solutions that they have been trying to sell is basically everybody holds everybody else's data, and no one wants to do that. So that's why these type of private blockchain networks 99.9% of the times fail after a while. But now everybody has a throat to choke and to blame if something goes wrong, which is lovely. So it's a marriage made in heaven.
Well, you know what, I was just thinking this morning, just real quick about zero knowledge, and just like we get into the technical side of it. And then when you pull back, like I went to Dunkin' Donuts this morning. This isn't an advertisement, nor should I probably be going there as much as I do, but I went there. I paid with my credit card, and the person could easily see my name. And then I drive away and they've got my license plate that's attached to it. And it's like our identity, our information is just being put out there. And we have this technology that can be used in such a simple way to change day to day, and then we're seeing it being used in all these fascinating ways. But it really like just comes to what information do we want others to have in many different ways. And I think you wanted to talk, I know, Kent, you were going to say something else about this or point to Dustin, but I just think it's interesting how we see use cases for zero knowledge every day.
Yeah, it's amazing. Like, I don't want to use a buzzword or sound like hyperbole, but ZKPs really are a game changer, I think, increasingly, especially as things like proof sizes get more efficient and all this stuff that happens in the background. I want to hear from Jeff shortly about kind of, from his perspective as a sort of somebody that's employing this tech, somebody that's coming from a background of, this telecom background. It's fascinating to me. Before we do that, I'm just curious, Dustin, as somebody that's really delved into zero knowledge proofs heavily, even as part of kind of our work here at C4, doing potentially, some cool badge stuff. Just any other perspectives or insights you have around, how this has been employed to date, and maybe what excites you about zero knowledge proofs?
Well, I think the big thing about zero knowledge proofs is that we use zero knowledge proofs a lot, but currently they're used for compression. They're not really used for privacy preservation. So you have all these ZK EVMs and they're using zero knowledge, but they're using it like they're using like WinZip. They're using it to make transactions smaller. They're not actually preserving privacy. Things like Aztec Connect are, but that is a minority. So I think that point of zero knowledge, or the big point of zero knowledge, is actually privacy preservation. And I think there are lots of use cases for enterprise, particularly with rules around data laws. When you are going across jurisdictions, there is a lot of compliance in terms of data privacy, especially when you're talking about consortiums that have to deal with each other, deal with competitors. So the opportunity is there to actually solve a problem for the enterprise, and then that allows zero knowledge to take on this sheen of actually solving problems for businesses rather than being this thing that money launderers and criminals use.
Well said. Yeah, great reminder. But one of the first, visible and common uses of zero knowledge in the crypto space was Zcash, of course, which implies ZK snarks. That's for privacy, basically. It's a good reminder also, we often think about privacy in the context of a fundamental human right, and also a hedge against authoritarianism. In the corporate context and just the broader business context, privacy is so essential in terms of just maintaining strategic privacy. How do you share information but not sort of tip your hand with certain important elements, which is crucial. I think that probably figures into what Jeff is looking at, and what Sage is digging into. Jeff, this to me is really interesting because this is something that previously you were not working with blockchain tech. So kind of like, how did you start learning and caring about blockchain technology? And then, what do you think about this implementation with Interweave is so powerful? And also on the same note, what are some of the maybe challenges to adoption? Sorry, I gave you a 3-part question there.
Yeah, well, let me see if I can get all those. So, all right, appreciate it. So, just a little bit of context. I mentioned earlier, like the buying of connectivity from one telecom carrier to another is the space that we spend most of our time in, and oftentimes among the larger carriers, they're trading partners. On one side, they're buying from, and on the other side, they're selling part of their network to their competitors, and then the invoicing that gets exchanged following the orders and the quotes and the contracts and everything that precedes it ends up having a lot of complexity to it. And so there's all of these disputes, these incorrect billings that are disputed. And nobody, neither the buyers nor the sellers in this telecom space, like the disputes. It creates all kinds of uncertainty about actual expense, revenue recognition, cash flows, and the like. Because they do end up being material in a lot of cases. And so, but the question is, how do you get to the other side of that? And several years ago, almost 5 years ago, we began working with a couple of domestic telecom carriers that were looking to get to the other side of a world where there are no disputes. And the path that was selected was a blockchain, a private blockchain-based solution. Blockchain, because it created some capabilities for them that simply a shared database did not. But private, because they weren't going to allow transactions, commercial terms and conditions, et cetera, to be obviously posted. And so the discussion for the past several years in the telecom space is that, yes, blockchain can be a solution for these carrier-to-carrier type of transactions to avoid disputes and there's other use cases as well. But the problem is that they're private. And then that kind of restricts it to the largest carriers who have the OpEx and the CapEx and the expertise to execute those things. And to get to a real, post-dispute world where carriers can feel confident about the revenue they're invoicing for, the invoices they've received that they're making payment on, where there are no disputes, you need to have a scalable solution that's available much more broadly. And that's about that time was when we got introduced to Andreas and the team here at Interweave, and they brought their solution to us for a way to provide a true scalable, private, secure platform that can be a game changer in telecom. I'm not sure if I got all three questions, Ken.
I guess the last one, and thank you for that. The last one I suppose would be sort of like as you contemplate this shift, is there anything that seems sort of like challenging, or this is such a step function, and maybe it's just a whole different way to utilize this technology as you move forward? How are you handling some of these maybe challenges that arise with adopting a new tech like this?
Yeah, so I think there's a lot of challenges that we're going to encounter here as we get this platform off the ground. That is a combination of Sage and Interweave. We expect that the chief data officer, the CTO, the CIO, accounting, legal, everybody is going to have to get very, very comfortable that what is occurring here in the ZK EVM environment that's obligating them for revenue and or expense and isn't revealing anything about the business. There's some hurdles between here and there. So it's a great opportunity, of course, to do some trials, leveraging test nets and whatnot. But yeah, I think there's a lot of those hurdles still in front of us, and we're working those at this time.
Thanks, Jeff. Question for Interweave team here. I'm a little unclear about, okay, so we have this idea of zero-knowledge proofs being very useful for sort of proving that some information exists or it has some sort of integrity without revealing the kind of private aspect of it, a powerful thing. How does the actual blockchain technology figure into this in terms of leveraging kind of those superpowers of especially immutability? I know this can be especially important in like an enterprise context where you want to know something has data integrity and is immutable and is nicely time-stamped. That functionality hypothetically has really been all around since the Bitcoin blockchain. You could hash something, post it on there. But what blockchain or blockchain environments does Interweave plan on using for this? And then as a related question, how does it plan on tapping into like scalability? Because of course, posting things, say, for example, if you were using like Ethereum mainnet to post things to the blockchain, this would get prohibitively expensive. So kind of just some clarity around those questions with respect to immutability and the blockchain.
Sure. So let me just make this very clear. We are using an existing layer 2 scalability solution. It uses zkEVM Rollup. As it comes out of the box with a couple of tweaks. So we're leveraging exactly the same tech that is already in production right now on public mainnet, except that with all the ZK EVMs like Linea and Polygon ZK EVM and so forth, they are open, right? Which means you can see you can see everything, right? the ZK aspect of a ZK EVM or any ZK rollup is not privacy. Right? The privacy we establish because we're the operator of that centralized compute environment, the ZK EVM. We control who can see what. We encrypt everything, right? So we are controlling who can see what in that compute environment, which is the ZK EVM, right? Now, what we're using ZK for is to generate a proof, highly compressed proof, that all the transactions were executed on the ZK EVM. So in a regular Ethereum virtual machine, Solidity smart contracts being executed just like normally goes on public Ethereum or an Arbitrum or in Linea, Polygon ZK EVM, Scroll, whatever, like, but we are using that and we're posting the proof together with the cryptographic fingerprint of the transactions that happened in a block onto public mainnet. So we're not incurring any more cost than a regular ZK EVM rollup would do. Especially now with the latest Koon upgrade, the cost for hosting these rollup transactions and proofs on public Ethereum has dropped dramatically. Right, I don't want to go into the whole details of like dank sharding and all of that good stuff. But so the costs are going down. Scalability goes up. We're using the public blockchain just basically as a New York Times personal section. Basically, we're posting something like you could post a hash in the New York Times. Everybody can read it. No one knows what it is, but it's like, oh, okay. But in this case, you can actually do a little bit more. You can actually verify that the proof is correct and that everything that happens somewhere up there that no one can see is actually done correctly. So that's the thing, and that's really important. So we're inheriting all the security guarantees of public Ethereum, which private blockchains cannot, while maintaining the enterprise requirements around privacy, verifiability, security, obviously. So that's the key. That's the key here. So if you want to compare it into a private blockchain, rather than having 15 nodes, there's one. But that's okay because we can prove that whatever happens on the one node is actually 100% correct, even though no one can see what happens in that one node.
And I'm glad you brought up, Andreas, Koon 4844. That is a different rabbit hole, but for those viewers who have been watching us over the past month or so, we did cover that recently, and it's such a game changer for making these implementations, these ZK rollups cheaper. Just to clarify, the ZK EVM is sort of a generalized term that can be provided or pasted onto various rollups that employ that tech. We have Linea, we have Polygon, and others. Have you settled on a particular ZK EVM implementation like a Polygon, or is this just being designed so any ZK EVM?
We're using Linea.
Linea, okay, which is, if I'm not mistaken, is actually a consensus-based rollup project, if I have my mesh knowledge right. Is that correct?
Yes.
That is correct. Yes.
Consensus Software Inc., not Consensus Mesh. Consensus Software Inc.
Cool. Thank you.
So the ones that are, the one that operate MetaMask and Infura and so forth. Those are that company.
So Dustin here, it looks like you brought up June Analytics showing just at a quick glance, I think this is showing some adoption post Koon of these blobs.
Quite interestingly, you're seeing that Linea has actually a lot of blobs posted over here. And recently they've put inscriptions on blobs, which is another thing. But yeah, you can see that Linea has actually got quite heavy blob usage on these particular days.
Interesting.
And
It's
a
cool to
reminder that blobs are binary large objects. And does anyone want to explain why we're showing this for the non-technical?
Just showing the adoption of blobs and L2s that are starting to use it. So you can see, just because blobs are enabled, blobs don't help with like L1 gas fees. They don't help with L1 block space, but they do help with L2s. So Koon can enable blobs, but the L2s need to adopt it. So you can see the adoption from the L2s here and who is using it the most.
So maybe just 30 seconds. So any data you post on public Ethereum costs money. The more data you post on, the more money, right? And L2s post a lot of data, so they have to pay a lot of money if they're posting it directly onto the blockchain, onto mainnet. With Koon, they can post that large data blob, not to the blockchain, not to mainnet, but to these blobs that are actually maintained by the validators of Ethereum mainnet, not the execution client. That's the key thing, and that data does not have to be maintained past 18 days. 4,096 epochs, right? It's about 18 days. So that data is going to go away. So that's why L2s are now also making that data available long-term through what I call data availability solutions, like Celestia, Eigenlayer, and so forth. So even though probably a lot of validators will get into the data availability game and just keep the data around, they don't have to delete it. Now you can verify that whatever data you posted to the blob is actually correct by using new capabilities, new blob transactions, and new precompiled to prove that the blob data was correct. So that's the nut of it. It allows to use a lot of data, not pay that much for it. There's all kinds of interesting stuff around. There's gas is now blob gas versus regular gas, and all kinds of fun stuff that's going to evolve over the next couple of years as this is being adopted. But for us, from an enterprise point of view, it's primarily making things cheaper for us, which is good because it's we can pass on those cost savings to our customers.
A few years ago, Ethereum collectively decided to take a very roll-up centric path with respect to scalability, as opposed to a sharding approach, which was kind of the first kind of thought towards scaling. And this is really part and parcel of that strategy. Is okay, well, if it's all going to be roll-ups, they should be very cheap. I guess very is a relative term, but just in terms of how cheap it is to use roll-ups, following Koon. Previously, rollups had to post into what's called call data on the mainnet. This is expensive and certainly not extensible into the future. So I think at least an order of magnitude cheaper and possibly much more, I think, is what we're already seeing. There's probably a lot of data on that. Hence, you're seeing these blobs being used heavily, and this is going to drive use of rollups across the board. And I think really introduce tons of new use cases that haven't really been thought of before, because now we have scalability, which is just so cool. Let's see. So what is now that this aspect is actually live, it's not really theoretical anymore. Kind of what's next for Interweave? You guys have spun out. You guys are working with people in the sort of real world of enterprise, clients. What do you guys plan on doing next?
Yes, so luckily we will have our hands full rolling this solution out with our partners at Sage. It's a really exciting place to be for us right now. I think it was a long time coming, where when we first started doing this research, there was a vast world out there of exploration for how we can apply this to so many industries. At one point, we were doing some work in the insurance space, the mobility space, and then dabbling in the telecom space when this started. And Andreas was involved in some of that and some of the cross-industry use cases. So it just gets exciting. You can fall down those rabbit holes quickly when you're thinking through that pattern of what's a situation that I know of where two or more parties need to coordinate and don't trust each other. So when you think of healthcare and you think of all the industries out there, it's a super fun thought process to go through, but that's kind of the type of problem that we're aiming to solve. And when we got connected with the telecom space where they're actually working on similar problems and needs, and we were able to plug ourselves in as technical experts who understand some of the more cutting edge novel needs to actually make it possible. We were super excited because we're not needing to explain things like what is blockchain to people. We're just so far past that conversation and talking about the actual value, and the technical people are talking to the technical people about actually implementing things to existing solutions. And then the business people are working with the business people about cost savings. And it's just nice to kind of be past the point of like, well, what is a blockchain? Because, those of us involved in the enterprise Ethereum space know that that's a very slow moving area. And I think it's because there's a lot of pressure to explain things like a blockchain properly. But when you focus on the problems and who's aiming to solve them, you get lucky to partner up with a group like Sage that is working on the same problems. And it's almost like we didn't know we needed each other until we started working together, and we got to the next step so much quicker than we expected. So that was really exciting to see just how quickly and eager the telecom space is to solve these same problems. I think they don't have some of the very strenuous data privacy concerns that other industries would have, like healthcare. So we're able to just actually start piloting and trying things out, which is super exciting. And yeah, that's kind of what I wanted to say about where we're going next. Is we'll be right here on the same boat with Sage. Rolling this out, we're going to be launching our beta service very soon. Working on locking in which telecom providers will be signed up for that, and just building out the solution while the technology is still so fresh and being built as well. So we'll be working on that. And what's exciting is Mark brought up this point of ERP, enterprise resource planning, early on, which is like the normal systems. Mark, you can feel free to totally say I'm explaining it wrong, but it's how companies operate internally. But what we're doing now is helping them actually operate across companies. But what's exciting is right now, the use case we're focusing on for SLA assurance, this one piece, this one module is part of a larger stack of all the different use cases that can be pieced together for this solution that ultimately helps us automate business, I guess. But Jeff, feel free to hop in.
Jeff, I'd love to hear your perspective.
Yeah, no. So like I said, several years ago, we got involved in blockchain, and the goal really was for carriers to move to a world in which they could trust the invoices that they're exchanging from each other. And yes, we do, by the way, just as a tangent, we do see a space where eventually there aren't invoices. It's only, a shared solution, right? The shared single source of truth. There's a number of use cases, like Somo said. Many of the use cases that have been deployed in the past have been around sort of the rating of services before invoices are exchanged, et cetera. But we're actually focused on another aspect of it, which is a really good use case to step into this space because nobody else is doing this use case. And it relates to trouble tickets. Like I mentioned, these large telecoms buy connectivity from each other. Everybody knows connections go down, trouble tickets are opened. Who's at fault for the trouble ticket is one aspect to it. And then there's another aspect to agreeing to what is the duration of the outage, and therefore, according to a schedule, what amount of credit might be due from the seller to the buyer under all those conditions. And today, this is a mind-numbingly difficult thing to do. They're relatively small dollars, relatively many such activities. And so having actually an automated way of having the buyer and the seller provide input into a process that then we feed over to the zero knowledge platform that allows for mutual endorsement to see if the buyer and the seller agree on most aspects of the outage, and then therefore there are no disputes. So now there's just a knowledge that these are the tickets where credit was due, these are the ones where no credit is due. And so it's a great use case, but we see the path forward of then getting into rating orders at the time of orders, and eventually getting to a space where using other technology where the invoices themselves no longer are necessary, right?
Oh
Hey,
my
Jeff,
God, how
correct me if I'm
incredible.
wrong, but sorry, Jeff, really one quick question for Jeff. Because this is really exciting. So it seems to me that if everything goes as you guys expect, and I think it will, because this is such powerful tech, and you guys have identified some ways in which it really improves upon the way things have been done. But I think this will engender, your success will engender more related enterprises kind of adopting this tech. As more enterprises, like say in telecom specifically, use this, then it'll actually make the use case even more powerful, because there's just eventually there's kind of a critical mass. Am I kind of reading that right as far as how things might play out in the future?
Yeah, I think so. I mean, so there's definitely a network effect here, right? So just example, you take a large, say, European carrier who is buying and selling with, let's just say 5 other, and of course, that's many, many more than that. But let's just say that they agree with 5 other carriers to be a part of this SLA solution, or later a rated order solution. But each of those partners have other partners also, and they say, hey, this is great, why don't I add these people to it? So there's this great network effect that happens in this space. That's what we're expecting. And then we do think eventually it goes beyond the wholesale, because everything I've talked about so far is really between the 2 carriers and the way they buy connectivity. But they do all of that in service of an enterprise who asked them for a particular service. And could all of this then be applicable on the retail customer facing side? Of course it could, right? So yeah, very exciting space.
And that's only for SLA, right? I mean, this is just one module, right? As in the ERP world, there are many different modules for very different things, right? You have a sales module, you have an inventory management module, you have a financial accounting module, right? You have a logistics module. All of this can be mapped into a cohesive solution. So you have end-to-end processing of multi-enterprise business processes. So enterprises collaborating together, selling joint services, right? So, one example is, it's like when you have a mobile service in your car, that is a composite service, right? Because there's connectivity, but there's also security aspect to that. Now you can roll in other services, right? You can roll in usage-based insurance, electric vehicle charging service, all into one. And that is then sold not by a single entity, but by a cooperative, a digital cooperative. So because we are now operating in a joint space in this ZK EVM, you have now, if you have 1,000 companies on it operating, you can now create these digital cooperatives, right? The equivalent of DAOs in public Ethereum, but with very different aims, right? There's about ensuring that, because they form long digital supply chains around data services, security, etc. Now you have the opportunity to manage inventory jointly, to settle billing jointly, instantly, to have visibility into network failures, not only to your next partner, but for the entire supply chain. Because when you're connecting an office from Singapore to London, there are probably 4 different carriers involved, and the last carrier doesn't know who the first carrier is. So, but visibility into the supply chain is key, because they know is inventory that they said, the connectivity service that they said they would have actually available? Was there an issue somewhere down in the supply chain that caused the failure of my service to my customer that my customer is now yelling at me for, and it was not even my fault, right? So all of this is now possible because you're operating in this joint secure space. And one thing I wanted to add about sort of like adoption and challenges. So I just want to say, if Microsoft hadn't been so dominant in in the server and desktop space in the 90s, we still wouldn't have an internet. Because everybody was going like, no, it's like, I don't want to work together. It's like my intranet, everybody, no, right? But when Microsoft rolled out TCP/IP with Windows 95, guess what? Everybody had to collaborate. The space opened up because now all of a sudden everybody was using the same tech, was connected to one another publicly, freely. And that opened up a whole new world of business opportunities.
I love that historical analogy. That's very apt.
Right. So we're hoping that this is going to be, it's going to be a little slower, but we hope that we'll have as these type of opportunities come up, and they come up because the demand is there, right? The demand for generative AI services on the fly, right? Requiring high throughput data compute, edge compute. Like all these services are being offered by these carriers. So and this business is exploding, and they cannot manage it point to point. So that's a Gordic knot. That's a complexity that no one can manage. It's not scalable. So we're anticipating that the demand pull and the fact that demand pull has direct impact on the balance sheet. And if the demand pull goes up and you can't meet that your balance sheet goes down, you're going to say, begrudgingly, they'll say, well, kind of, we have to work together to make this stuff work. So that's our hope. Not our hope, but we know that this is going to happen because the pressure is there. The sales pressure is there from the demand side. And with generative AI, it's exponentially increasing. All the carriers are going like, oh, crap, what am I going to do now? How am I going to manage that? Not only like 2 years from now.
That's a powerful vision.
What sounds really interesting? What sounds really interesting about that is like we're so used to in crypto of like, the concept of composability and how like we have all these money Legos that can build together, but it feels like this is a platform that can enable this for the enterprise, where all of these composable parts or services that enterprises would be able to collaborate with each other, but they have walled gardens that they don't necessarily have the shared trust, or why should I do it on your platform because I don't
Correct.
believe that I'll be treated fairly on your platform, whereas this is something that is a public good. This is something that is run not, it's not run by a particular company, it's not run by a particular consortium, but it's run openly with an open standard, and that everyone can collaborate and everyone can start seeing the benefits of being part of the corpus of what goods can come from this public good.
Hopefully, we see that there is going to be a weave of these enterprise solutions connected by bridges, right? Because it will take a while. Just like you had with the internet, you had these intranets, and they were still connected to other intranets, right, through the public internet. So we see something similar gonna happen, when people are gonna try things out, and then they see the advantages, and then they'll be part many of these different layer twos for different industries, for different solutions, for different offerings. So we're that will probably take a few years, but typically once enterprises see that there's a significant impact from a revenue and cost saving point of view, they'll just do it. You know, whether they really understand the tech or not, like everybody is using generative AI. Does anyone understand this? No, no one.
Hey,
Zero.
speaking of tech, just I want to close things out on just a slightly techy question, because here at C4 we do love the tech. This maybe is better directed towards Mark, but you guys are building on Linea, which, like all rollups and all ZK rollups, are sort of a relatively new technology that are sort of many are kind of taking this route towards sort of progressive decentralization with respect to, like, you know, sequencers and things like that. How does kind of the ever-changing nature of ZK rollups and Linea specifically, knowing the Linea tech is kind of evolving over time, how does that kind of inform what you guys are doing on the tech side, building and operating on this rollup?
So
Yeah, sure.
Sorry, Mark.
It's a little unique just because we're using our Linea ZK EVM as a custom enterprise solution. We don't have to keep pace with the upgrades to ZK EVMs in the same way that you would need to if it's a public solution. So it's just more of a pragmatic point for us. If it makes sense to go along with an upgrade, we will, but we don't necessarily need to. And like Andreas mentioned already, we're the way we're running our ZK EVM is just from the perspective of a singular node. We only need one node to execute our smart contracts, only one node to prove that they all ran successfully. So the big talk about prover, decentralization, things like that, it's not quite as important for us because we aren't building a open, decentralized ZK EVM blockchain. It's simply just a trusted execution environment leveraged for a very singular purpose in our case.
Oh, that makes sense.
Right, and from a you know, the EVM is going to be the EVM, right? That is going to evolve over time, but it's going to be backwards compatible and will maintain the state. That's not going to change, right? So because of backwards compatibility reason, so all the technical evolution in the ZK EVM rollups is happening on the prover side, right? And basically what you're doing in the ZK EVM, and let me just be like geeky for like 30 seconds, is you're executing the smart contract, and then you're executing the smart contract again, but you're proving it out. So you actually have the solution, and then you're checking that all of this was done, and then you post the proof. That second execution, that is what's evolving. This one, that's okay. That's not really problematic. And by the way, what you just showed just in the risk analysis, that again is focused on public. Do we care about exits? No. Do we care about you know, it's like that you can move, you know, cryptocurrency from public mainnet into up? No. Do we care about sequencer failure? We are running in a Kubernetes cluster. There is no sequencer failure, unless you know, it's like we can set it up such that even if the entire availability zone in a cloud environment goes down, we'll still be running unless all the availability zones fail, right? So it's like not relevant, right? So that's that's key. So we can gain the advantages of the new development, whether that's new prover systems that are you know, folding schemes, ZK ASICs and FPGAs, very exciting. All this can be used without interrupting our normal operation.
And this really speaks to one of the advantages of ZK rollups, is they can really kind of be applied to the specific use cases and kind of parameters and desires for you know, trust minimization of every implementation. This is a good example where, you know, we always think about having to have that maximal decentralization. In this case, it's not necessary because of what you guys are doing. We're actually at time right now. I feel like we could keep chatting for much longer, but this has been a really cool chat. Thank you very much, Mark, Andreas, and Jeff, and of course Sonal.
Dustin had one more question. It's like I think he wanted to ask.
Yeah, I had one more question. Essentially, there have been some cases where there have been ZK soundness bugs. So I think that it's been encountered with like a ZK sync error. There's one, and then there was another with like comparing. So I'm just wondering, what are the kinds of risk factors? Because ZK is moon math, which a lot of people don't understand, and like soundness bugs are, a real risk, even though there's a lot more work that needs to be done with the audits of the soundness for the ZK. So what do you think the risk factors are for this?
So I can speak to that. So soundness bugs are really only relevant about if you want to fake proofs, right? And have fake state proofs that you use for withdrawals, right? That's the problem, right? It's like if I can do that, then I can front run these validity proofs and post something into the, or I can exit, which is currently not really
right.
possible. It's so there's a dirty little secret around VK EVMs is that any state machine, you can't really do exits because you do not control the state of your asset atomistically. You do if you have UTXO based models like Aztec Connect and something like that has, or if you can pause like with everything is transparent, but you can't with tangled state. You can't. It's
no,
just
with account-based models, right?
Yeah, it's account-based models. It's not possible. Right? Well, it is possible only if you have private state, and within that private state, you can then do it. You can do it. It's very hard to do. So I've done work in that, but the soundness bugs are really only relevant for the point when you can post proofs, state proofs that allow you to withdraw funds.
Yeah.
So
the exploitation vectors are a very narrow subset.
Very, very narrow. So it's like in this case, it's like, who cares? Now, if you were to use the zero-knowledge proofs derived for something else to actually hide information, that's a different story. When you have circuits where you're making statements about knowledge, not about correctness, right? Then it becomes more problematic. But again, these bugs are very hard to exploit, and you really need to know what you're doing. And and things evolve. Obviously, the tech is evolving. The prover systems are typically secure, as with everything in cryptography. And I'll leave you with that. If your implementation is not done correctly, and it's very hard to implement things 100% correctly, then your mathematical security proof is not worth anything.
Awesome. I think what this shows is that the technical soundness is there and the people in the weeds know what they're talking about, which is awesome. And then some of us at the higher levels, we're all still aligned. And I think what's important is that we're starting to see eye to eye with real business people to solve the problems in that space. And I think we're making progress in adoption, which I think is one of the most exciting things for myself, at least.
Yeah. One of the core things here that I'm seeing and thinking is, there are people out there that say, well, blockchain technology has no use beyond just, speculation and whatever, but it's demonstrably false. just looking at what you guys are building and doing right now. So having a window into this is so cool. If you guys want to learn more about these respective projects, that's Interweave and Sage in the telecom sector. Thank you very much for joining us today. And of course, here at C4, we're all about educating around this. So if some of what we talked about seemed a little bit confusing, or you're not quite up to snuff in terms of like, okay, what are we talking about with ZK rollups, and maybe even some of the finer points of what Dustin and Andreas were just talking about. This is certainly stuff that we've touched on in the past and likely will go deeper on in the future. So, we are your non-hype, genuine resource for this tech, and will remain so in the future. I guess we'll leave it with that, but great chat, everybody. Good hanging out.
Thank you.
Thank you.
Thank you for having
Thank you
us.
so much.
Really
Thank you.
appreciate the opportunity.